This is Jeff Trotman. Thanks for tuning in to Networking for Developers. This is part 2. Today we're going to talk about the subnet mask. In part 1, we introduced the concept of a local and remote network communication and how in certain cases when a source computer is sending packets to a destination computer, it's a local conversation when the two computers are on the same network. But in a more complicated situation, like when you're communicating across the internet, the destination computer is remote and you need routers to help. You can think of routers as like the post office of the internet, and get packets between the source and destination when they can't communicate directly. So, but the subnet mask is what your computer or the sending computer needs to determine the computer that I'm trying to communicate with, is it local or remote? So let's look into the details of how your computer does this with the subnet mask. So when you get IP configuration, normally this happens automatically. There's something called the DHCP server on your network that assigns an IP address, a default gateway, and a subnet mask. But these are the three sort of core things that you need. You're also going to need a DNS server, but that's beyond how complicated we want to get today. The default gateway is kind of an old term for router. And what that is that's the IP address. It's kind of the address of the post office, if you want to think of it that way. So if your computer determines that who the destination that it's trying to communicate with is remote or far, instead of communicating directly, it's going to drop off the packet at the post office, the router, and the router is going to get it the rest of the way there. The subnet mask is a tool that your computer is going to use to compare its address and the destination address and decide, is this a local or remote conversation that I'm about to have when I try and send this packet. So because computers think in binary, it's very cumbersome for human communication to deal with binary, but we're going to get into that a little bit right now. The subnet mask in base 10, 255.255.255.0, the equivalent of that is what I'm showing here. 8 ones, 8 ones, 8 ones, 8 zeros. The binary equivalent of 255 is 8 ones. If you want to get out the Windows calculator and switch over to programmer mode, you can verify this. I'm going to put a link in the notes. I've got a different video on understanding binary and decimal and even hex a little bit better. But so for today, you don't necessarily need to understand the conversion that much, but it's just helpful to visualize this, and I'll show you why in a second. So a subnet mask is always going to look like this in the sense of going left to right. It's a series of ones followed by a series of zeros. And the number of ones and the number of zeros may change, but it'll always be ones on the left, zeros on the right. They won't be interspersed. What this is indicating is the transition point when it switches from ones to zeros. That's saying of the 32 bits in an IP address, in this case, 24 of the 32 bits are used for the network address, and the remaining 8 are host address on that unique network. Let's use an example, and that may make more sense. So if my computer is 192.168.10.1, and I'm sending a packet to another computer, 192.168.10.100, and both computers have a subnet mask of 255.255.255.0. That format right after that says /24, that's just an alternative way of saying IP address of 192.168.10.1 with a subnet mask of 255.255.255.0. The /24 means how many network bits or how many ones on the left. So if we convert those decimal values to binary, and then I'm going to redraw them here, and here is, we're going to bisect with that line the addresses where the subnet mask changes from 1 to 0. We're going to redraw them over here with spaces, and you can now see that the binary source IP and the binary destination IP have got the same network address. And so what this means is from 192.168.10.1, sending a packet to 192.168.10.100 is a local conversation, and that can happen directly. No router is needed to get it from point A to point B. That's the whole point of a subnet mask, is to in different networks that can be divided at different places. And it's a little bit confusing, but this is what a subnet mask is telling you. Let's do a second example. In this case, we got the same two IP addresses, same source, same destination, but I've got a different subnet mask. This time, instead of the last one being .0, it's .240, which is equivalent to 28 ones out of the 32. So converting to binary, redrawing, and now where the line is a little bit further to the right. So more bits, this time 28 as opposed to 24, are involved in the network part of the address as opposed to that. When I split that up and then look at the network address of the source and the destination, you can see they're different. So this means even though the addresses didn't change, because this means that the configuration of the network where those are changed. And so this is now a remote conversation. So the device at 192.168.10.1, if it wants to send to .100, it can't communicate directly with it, because what we're seeing here is they're on two different networks. So the device ending in .1 is going to have to pass that packet to its router that's specified in its default gateway, and the router is going to get the packet from the .1 address to the 100 address, because you're actually crossing networks at this point. Just real quick, want to talk about powers of 2 having to do with binary, and we are getting into this a little bit, but when I have a mask of 255, 255, 2550, like we said, that's 24 ones and 8 zeros at the end. So the way with 8 binary digits, which is what I've got, that's 256 unique combinations. The way to figure that out is 2 to the n, where n is the number of binary digits. So in this case, the top line, 2 to the 8th is 256. That almost means that I can have 256 unique host addresses on a network configured with this mask, but there's always, I have to subtract 2. I don't want to get into all the details of this. One of those is a broadcast, but this is just a thing to be aware of. When you're dealing with something, the top row, it's not that big of a deal. But in situations where you might run into, if you're getting, for a small business, you're setting up internet service and they are assigning you public IP addresses, which we're going to talk public and private in the next edition. But they're probably not going to give you 256 in a typical small business. It's probably going to be one of the remaining 3. So if they give you a subnet mask of 240 is the last decimal quartet, you could, that means there's 4 digits left for the host. You can store 16 unique values there, but you're only going to be able to use 4 of them. Again, you always have to subtract 2 wherever you draw the subnet. If they give you a mask of .48, there's 8 IP addresses, but they will typically say only 6 are usable. And the smallest one and the largest one are the ones that are unusable. If they give you a mask of .252, which is about as small as you can go, you're only going to end up with 2 usable IP addresses. So even if all that you want is 1 public IP, you're typically going to get something like that. So anyway, that's how the subnet mask is used. Next time we are going to get into the difference of public and private IP, but Thanks for watching Networking for Developers, brought to you by Circlebox and CBITS. Again, I'm Jeff Trotman.